This is a video for the SQL injection attack lab. A SQL injection attack is inserting a portion of a SQL query into the vulnerable query being run by the program. This corrupts the query and allows the attacker to access the database. The first task of this lab is to print all profile information for employee Ellis. We can do this by go ahead and logging into MySQL. With MySQL root.pcdubuntu. From there we can go ahead and specify that we're going to go ahead and be using the users database. Then we can go ahead and show the tables within the database. As you can see here, there's only one table within the users database, which is credential. Doing that, we can go ahead and select everything from credential where the name is equal to Alice. As we can see here, this is all of Alice's information retrieved from the database, thus completing task number 1. Task number 2 is getting into the SQL injection part. So you're asked to use this website and SQL injection in order to log into the admin's account, but only knowing that the username is equal to admin. This is possible using SQL injection. You can go ahead and manipulate the vulnerable SQL query that's being performed here. So basically the input.username is this text field here, and the input.password is this here. We're going to be using the username text field because it is of type string, which we are able to input the portions of the SQL queries. So one way of doing this is using admin, using a single quote, and then a space and a £. With that, we are able to log into the admin account, seen here, with all the information from everyone else. This is done because we exploited this vulnerable query, which is considered to be vulnerable because we expect the inputs from these from the user before the thing is compiled or run together. So basically, the input from the user and the query get compiled or run at the same time. That is considered to be vulnerable. So basically what we typed in here, which was the admin single quote space £, is manipulating this field right here. So we would basically just put where the name is equal to admin, and then that £, commented all this field out, so where it's just basically name is equal to admin, allowing us access without needing the password. So that completes task 2.1. Going on to task 2.2, we are asked to do the same thing except through the terminal. So if we go ahead and open up a new terminal, we are able to go ahead and perform the same thing. So we're going to be using curl, we're going to be opening and closing single quotes. We're going to be adding in www.seedlabsql injection .com/unsafe home.php. We're going to be adding a question mark in order to append a username that is equal to admin. We're going to be adding a %27, which is going to be that single quote. %20, which is going to be the white space, and a %23, which is going to be the pound sign. If we go ahead and press enter, we can see that we went ahead and got this code back from the website through the terminal. So this code here is the information we saw over here on the website if we went ahead and accessed to admin. So the information from the admin account is displayed within the terminal here. So the attack is a success as well. Next, for task 2.3, we are asked to append from the website. We can go ahead and append SQL statements by using the semicolon. So example would be, go ahead and kill that field. Go ahead and set it equal to true for fun. Go ahead and append another SQL statement. We are asked to go ahead and attempt to delete from the credential. Let's just say where the name is equal to Ted, because Ted was originally in the database. We go ahead and put a semicolon and a pound sign. We go ahead and test the code query. We can see here that it was rejected. This is due to the C labs actually preventing two queries being appended within the website. So this is expected to fail. However, you would append two queries together by using the semicolon and starting the new query from scratch by using the condition from where and from what table. This completes 2.3. Going on to 3.1, we are asked to modify Alice's salary because Alice asked her boss for a raise. Her boss Bobby denied, so she's just going to go behind his back and increase her salary anyway. So we're going to go ahead and log into Alice's account, doing the same thing we did for admin. We are now here in Alice's account. As we can see, her salary is 20,000. We can go ahead and edit that here. We can go ahead and use the name text field as it is string, which would enable us to exploit the update query here through SQL injection. So what we can go ahead and enter is a closing single quote, a comma, salary. Let's say her salary is equal to 500,000. We're going to say where the EID is equal to 10,000. That 10,000 being Alice's EID. We're going to go ahead and close that with a semicolon and add a pound sign. We go ahead and run that. You see that her salary was changed from that 20,000 to 500,000. So she basically just gave herself a raise, even though that text field is not here for the updating, but she was able to bypass that through SQL injection. That completes task 3.1. Going on to task 3.2, she's still mad at her boss Bobby, so she wants to decrease his salary to 1 from her profile here. She can go ahead and do that by ending that thing. Going and putting a comma, going and adding her new update field, which is going to be updating the salary to 1, where the name is equal. Well, I guess first I should show you what Bobby's salary is. So let's go ahead and log into Bobby's salary for a second. Bobby, as we can see here, Bobby's salary is $30,000. So since Alice is mad, she can go ahead and use SQL injection to go ahead and get back at him. So we set single quote, we use a comma to start a new statement. We go ahead and say that the salary is equal to 1, where the name is equal to Bobby. And then we go ahead and insert that. Nothing was changed here in the Alice's profile because her target was Bobby. So we go ahead and log back into Bobby. We can see that his salary changed from that 30,000 to the 1. Thus completing task 3.2. The next thing is that she wants to go ahead and change his password to go ahead and access his account whenever she wants. This can also be done through SQL injection, again by exploiting this vulnerable statement here. She's able to do that through the same field, but however, she would need to know his password, and the password is of type SHA-1. So in order for her to know the value of what password she's going to put in, she's going to need to go ahead and figure out what the encrypted password would be, since the password is encrypted and stored into the database. So let's go ahead and open up a new terminal. So we're going to go ahead and do echo -n. We're going to go ahead and input the password here in quotes. So let's just blame Ted. Why not? So we'll just put Ted was here. So if anyone's suspicious, so we'll just blame Ted. Then we'll go ahead and add a pipe symbol. And then SHA-1 sum. This will go ahead and display the equivalent for the SHA-1 encrypted for the plain text Ted was here. So we're going to go ahead and copy that because we're going to go ahead and need that. I'm going to go ahead and log into Alice's account again. Using the same nickname text field. We're going to go ahead and put the closing quote, the comma, password is equal to, go ahead and put 2 single quotes here because this is of type string for the password. However, we didn't use the password in the beginning because the password is, again, encrypted. So we can go ahead and put the equivalent of that encrypted password here. Go ahead and specify where the name is equal to Bobby. We can go ahead and end that with a semicolon and a pound sign. Can go ahead and check what Bobby's actual password, Bobby's encrypted password looked like by checking the field here. So we can just go ahead and select everything from credential where the name is equal to Bobby. As we can see here, Bobby's password started with B78ED. Let's go ahead and run our query. If we go ahead and run our query, nothing changes for Alice, But if we go back to the terminal and check what Bobby's password is now, we can see that it was changed to the 1B362. Well, 1B326 instead of the 178ED. Okay, so in other words, we were successful in changing his password. So if we go ahead and type in Bob for the username, and we went ahead and set it to Ted was here. Go ahead and select log in, and now we are in Bobby's account. So now we change Bobby's password and are able to log in whenever we want. The last part is task number 4, which is the prepared statement. We're just going to be the countermeasure. So what we're going to go ahead and do is use the terminal to go ahead and open up some files through Sublime. But first we need to get to them, so we can just do var www SQL injection. Oh, oops. Forgot the CD. As we see here, there is the unsafe home, which we exploited before, and there is also the safe and the unsafe home, as we can see here. So like I said before, we're going to use Sublime. We're going to do safe home.php. I'm also going to do the same thing for the unsafe home. So as we can see here, the two unsafe homes are side by side. So what we want to go ahead and do is change this unsafe home to be safe. So basically what made this file unsafe is the SQL injection here, which is to select everything after the user enters something and then compiles the whole thing before it's actually manipulated. Over here in the safe home, you can see that the SQL uses prepare. So prepare statement is what makes this protected, because this prepare compiles the SQL statement before these two fields even get their values assigned to them. So we see here that the two values have the question marks for placeholders. So that placeholder is filled in by the bind params with the username and the password after this is compiled. So basically this is compiled before this is inserted, and when this is inserted, it's of type data. So it's basically just declaring its value. It won't be compiled. It's just like it's this, which kind of takes out the whole method for SQL injection. So in order to make this safe, just go ahead and copy this code here. Just go ahead and copy here. And since we killed that, we don't need any of this JSON. Okay, that was the only change we need to make it safe once again. Go ahead and do File, Save All. It's going to prompt us for the password. So the password for seed is going to be DEES. We authenticate it, so it has been saved. Let's go ahead and minimize that. Now we're going to go ahead and need to reboot the servers that the PHPs are running on. So we just go back to the root. back to the home. Go ahead and just do sudo service Apache 2 and then reset. Go ahead and enter DES again. Then we're going to go ahead and try to use SQL injection within this field here. So if we go ahead and type in admin, single quote space £, we got blocked, which is good because we are not able to exploit that select statement we did earlier through SQL injection. In other words, we were successful in passing task number 4. This concludes the C lab. That is it.